I have the rest of the midterm exam sheets for any of you if you didn't take it, you can come up to the class and pick it up. And as I said, if you have any questions about the midterm, you can come to my office. I had a bunch of you stop by my office last week and they got, I believe most of them, they got something. So we can discuss what did you do, how to do it right, and if you did it right, or you deserve more points, you're gonna get it, okay? All right, so over the last couple weeks, we have been discussing how to do structure analysis using SAP 2000. By the way, SAP 2000, as I said before, is not being used, in practical, because it's a general software. Usually, there's some people use it, I used to design buildings with it, there's nothing wrong with it, but it's a general software designed for general and structure analysis. But usually when you design buildings, you go to a specific software. When you design post-tension slab, you go to a specific software. When you design foundation, you go to another software. But SAP 2000 is a general, has everything. And I believe it's one of the strongest tools when you come to the design of retaining walls, tanks, stairs. It's really good with that. However, in this class, we need to do structure analysis for tall buildings because this is our course project. So I started with SAP 2000 because the thing is, all CSI softwares, SAP 2000, ETABS, SAFE, they all have the same interface, same thing. They are very close to each other. So that's why I started with SAP 2000 so that you can have a little bit of background about the interface of the CSI software. Once you know that, ETABS is going to be a piece of cake. All right. So today, what we're going to learn ETABS. It'll just be one lecture because it's a very clone from SAP 2000. So there's not much. If you look up there, almost the same tabs. But we are going to see how it is much easier to do structure analysis using ETABS. So if you guys remember our plan from last time, we're going to do the same one here on ETABS. Let's look here. That was the plan that we had from last time. We had like a 10-story building. This is the typical floor. It has a bunch of shear walls, a core, a marginal beam. And by the way, let me ask you, we talked about solid slab and flat slab system. What system is that for a floor system?
Flat slab.
Flat slab, right? Because right now I have the columns are directly without any beams. But if I have beams that way and beams that way and all the columns are connected with beam, that is called solid slab system. By the way, solid slab system is a very, very stiff system. More stiff than the flat slab system. However, the construction of solid slab system takes a lot of time, and to be honest, there's not a lot of people that are using solid slab system. Unless there's an area that really, really needs beam. Flat slab system is very easy, the construction is very simple, the labor is less, so that's why everyone is going with the flat slab system. Even if you have a really, really big span, they make the flat slab system post-tension so that they can overcome the long span. And we talked about this earlier. So let's see how we can do this plan on ETABS. So the same thing that we did last time, we have to find out the spacing between the grids. If you guys remember, we had grids in X and grids in Y. And we start with grid 0, and then 2.7, 7, and then 5, and then 14.5, and then I believe, and then another, you put this after 2.5, and then 5, and then this distance, and this distance. Same thing with Y. So we're going to do the same thing using the grid system. And at the end of the lecture, I'm going to show you how we can do this like this in 1 minute, without even doing grids. But let's do the typical way, the grid way. By the way, there's many ways that you can input your model into SAP 2000 ETABS. By the way, I only showed you how to draw your structure in SAP 2000. Sometimes we do everything on AutoCAD and we import it to SAP 2000 and we run the model right away. We don't have to do grids, we don't have to do everything. That's a way that we can do it in SAP 2000. I didn't talk that way because it's going to be very long, but I have videos on YouTube how to do it. Yeah.
Which software do we use to involve the drawing of our structure and the reinforcement that we are supposed to use? Like,
well, I know that you can import geometry, but you don't import reinforcement. Reinforcement, when it comes to design, you only you can put the reinforcement in the columns or something. But the thing is not going to add much to the stiffness of the building. Like when we make the column, we can assume a certain amount of reinforcement in the column. In terms of analysis, structure analysis, when we do structure analysis, we never mention if this cross section is reinforced or not. Because the thing is, reinforcement doesn't contribute that much to the stiffness. Like we used to do an example to the students when we teach reinforced concrete. It's really a good question. So, like, let's say that you have a beam. Can you turn on the light just 2 minutes? Like, when you have a beam like this, so we usually, when we do structure analysis for a beam like that, all right, I don't tell you if this beam is reinforced or not. Like, I'll tell you this is the cross section, but usually beams are reinforced. Reinforcement usually for the beams, for a central beam like this, is something in the middle like that, all right? That's a composite material, concrete and steel. Every one of them has different Young's models. So what we usually do, we converted this steel to its equivalent of the reinforced concrete. So you will end up with like this steel can be equivalent to a reinforced concrete at that much. So you have a cross section 1 and another section 2, and you have to make all of them at the same distance from the CG of the entire section. You have to find a different CG. When you try to find the inertia that comes from both, the contribution of this part is very, like, it's not as much that you like would do all that work for. So that's why we stay conservative with this, but this is definitely the right way to do it. So if you want to do it, you can do it. But the thing is, I don't think there's any way that you can import reinforcement from AutoCAD, because you import plans, geometry.
yeah.
You have to define this when you define the cross section. You remember when we define sections, beam 1, beam 2? So you include this when you define the section. Anyway, let's not talk about this, and let's focus on the ETABS. Can you turn on the light? All right. Oh, thank you so much. Okay, let's record here.
By the way,
I didn't upload the Zoom recording. But okay, I'm gonna check from last year, because I remember last year we recorded everything. So if anything missing, I'm gonna use last year recordings.
Professor, I have a question.
Were you guys able to find the recordings from last year? Like
Yeah.
when you go to YouTube, you can find it, right?
Yeah.
Okay. What's the question?
When are we going to be able to see like the requirements for the project?
Oh, you mean like the final presentation?
Mm-hmm.
It's gonna be at the last day of class.
No, I meant like the.
Oh, you
like,
want the project description?
Yeah.
I'm waiting until we finish the lateral load analysis and lateral load design, then I would give you the project.
So we're going to be using spectrums.
Like we are going to, maybe after next week, maybe I would send the project description so you guys can start building on ETABS.
Okay.
Okay, let me share my screen. Okay, so here's ETABS. When you open ETABS, it's gonna show up something like this. Same thing that we did for SAP 2000. You're gonna say File, and you're gonna have a new model. All the tabs are deactivated because you don't have a new model in the system. So I'm gonna say new model. If you guys remember in ETABS, when you say new model, it's gonna ask you about the units, about if you want to start with typical things. Same thing here. Because ETABS, it's heavily used for design. It asks you about what units that you want to use. So I'm going to use the built-in units. I don't want to use the user default settings. I'm going to use built-in settings, and I'm going to use units that are metric. If you want to decide on the region, I can decide on the codes that I'm going to use for design but I'm not gonna do design with ETABS, so it doesn't matter much for me. So if you want to pick like ACI or AISC for steel, so you can choose whatever. All what I care about right now is the unit. Then I hit OK. So once you hit OK, it's gonna ask you, because usually SAP 2000 doesn't have truss, doesn't have tanks, doesn't have stairs, it's only buildings. So it asks you, what is the slab system of your building? Like, do you want to make a plank, like you are gonna do everything on your own? Or you want me to develop some grids for you to help you drawing? Or you wanna like start with one of the slab systems that I have. Like I have a steel system for a slab, I have a staggered truss for a slab. Staggered truss is something like, you guys, when you go to big stores like Walmart, Publix, look at the roof, it's like trusses. That's how the slab system of the truss, or the roof system of the truss. Truss, it's like a rib, and the rib is a truss system, and they are at a specific spacing. So that's kind of like, we can call it a truss ribbed slab. Here we have a waffle slab, can you see? And this is a two-way rib slab. So you have a rib here and rib here. That's a waffle slab because they are very closely spacing. This is flat slab, and I can see a drop panel in the middle. You can make the drop panel 0, or you can make a drop panel with a specific sequence. Here is a flat slab with a perimeter beam or a marginal beam, like the one that we have. We have a flat slab with a marginal beam all around. This one doesn't have a marginal beam. I can see the beam here. So what I'm gonna do, I'm gonna start with grids. I'm gonna do the same thing that I did for SAP 2000. Let's see how it's easy or difficult than SAP 2000. But also, the software gives you like the option. Do you want me to start with a specific story height? You can give me the number of stories of the building. Once you import, like if you said I want 10 stories, so he's gonna prepare the grid system or the slab system that you wanna start with. Here was the number of stories. Like let's say I pick flat slab and I said I have 10 stories, he's gonna make a building flat slab with 10 stories right away. So I'm gonna start with 1 story because I only wanna do 1 for now. And the typical story height, if you guys remember from last time, I'm gonna make it 3 meter or 10 foot. So, and actually ask you about the bottom story height, and this is because usually in tall buildings, the bottom story is the height is much higher than the other typical stories because that is the podium of the building. So let's just start with grids. And I'm gonna say that the number of stories is 1 for now. I'm gonna change it later. And the height is 3 meter, and the height of the bottom story is 3 meter. I'm gonna say okay. So here is gonna start a new model. So I'm gonna wait a little bit until it finishes. And actually, before I start doing anything, I'm gonna change the units. So I'm gonna come here to the units. I'm gonna make sure that the units are okay with me. It's millimeter. No, I want it to be meter. And the units here is ton force. I'm gonna make it ton force. Here, I can change the units. All right, I'm gonna do something really quick. I wanna customize. The thing is, I forgot, I asked him to do uniform grid spacing. So we basically developed these grids. Like I say I want 1 story, 3 and 3, so that's everything. But the thing is, he started with grids numbers. Like he started by 4 grids in X, 4 grids in Y, and the spacing is 6 meter. The thing is, I want to do my custom grid spacing, and you can come and edit them here. Okay, so this is the same thing like ETABS. If I, like let's say cancel, and if I said I want a uniform grid spacing, or I did it by mistake and I hit OK, you can come after he does that and click right click on the screen like this, and you say I want to add or modify grid system. So the thing is, he divides the grid's definition. If you guys remember in SAP 2000, he put X, Y, Z. Here, he divides the XY system from the floor system. And right now, there's no Z, it's a stories. So here is the grid system for the XY, and here is the grid system for the Z direction. And if you have 10 story, they are gonna show up as a 10-story here. So let's do modification to the grid system. So I'm gonna say modify and show. So actually it's showing me the grid system that he started with in the X direction and the Y direction. I wanna modify that. So if you guys remember the grids from last time, I have 0 and 2.75, if you remember. And then I have 7, and after 7, there's 5. Okay, there's something cool here, and actually that's much easier. You can display the grid data in ordinates or spacing. Like if you know the spacing between each grid, you can put the spacing. Like I don't have to accumulate, 2.75 and then 7 and then 12. So you can do that, or you can make the spacing. So actually I remember the ordinates, so I'm gonna leave them as ordinates. So it's 7 plus 5 is gonna be 12. And then I'm gonna add more, 14.5, and then 17, and then 22. This is 22 plus 7 is gonna be 29. So the last one is 29. And 29 minus 2.75, so it's going to be 26.25. That was the grid in the X direction. Let's make the grids in the Y direction. So I have 0, same thing, 2.75. And then I have 7. 7 plus 5, 12, and this is 1 meter. 7 and 12, 13, 13 plus 2, 13 plus 3, it's going to be 16, and 1 meter, 17. So I have here, this is 7, 12, 13, 13 plus 3, 16, plus 1, 17, 17 plus 5 is 22. And I have 2 more grids. One of them is 29, and the other one is 29. Minus is going to be 26.25. Alright, so that's all the grids that I have for now, so I'm going to say okay, and I'm gonna say okay. Damn. I don't know why. Oh, actually, it sounds like we messed up with one grid. It's over there. Let's see. 5, let's see what happened. That's the Y grids. Oh, so I have one here that is 275. I don't know how that happened.
You need to label that 10 or?
You can. 10. That's it. Okay. Alright. So now it makes sense. Alright, so this is the same grid system that we had from last time from SAP 2000. Let's see what is next. Do you guys remember after we drew the grids, what did we do?
Define.
Define what?
The material.
Materials. So I'm gonna go define materials. So you'll come here, you will find lots of materials, steel and concrete. So the first one I see here is steel. If you are gonna have a steel cross sections, you can come here, change the F yield or something. It says it's steel. And by the way, the units that's showing up to me here is kilonewton per meter cube. So if you wanted the units to be ton, so you have, actually you can, I believe, change them. Let's go to units and make sure that our units are customized to meter and ton force meter, and then we go back to material, find, steel is 7.8, which is the most important part. Whatsoe ratio is 0.3. So I believe most of the things that I need are there if I'm drawing a steel cross section. The Whatsoe ratio, Young's modulus, and the steel weight per unit volume. Same thing, the concrete, we have the 4,000 pound per square inch concrete from last time in SAP 2000, same thing. The weight per unit volume, 2.4, and modulus, Whatsoe ratio, that's all what I need right now. If you are gonna do design, so you have to input the design property data, so they make it here, you can include the concrete compressive strengths, or the characteristic compressive strengths FCU, and you can include the value of this here if you are gonna do design. And usually we use ETABS for design too. It's a very powerful tool in design. And then finish, you say, okay, your materials is already saved there. Same thing, define sections. You can go define frame section. So here you can add new property. You can make either concrete, steel, there's a lot of materials here. So I'm gonna say, I'm gonna make beam and rectangular beam. I'm gonna say beam 25 by 70 centimeter, and the material is concrete 4,000 per square inch. I'm gonna change the depth of the beam to 0.7 and the width of the beam to 0.25. And then I'm gonna hit okay. If you wanna change a modifier for the beam, if you wanna reduce the stiffness, increase the stiffness, and at some point when we do seismic, we reduce some stiffnesses, but this is where we are gonna do that. Let's not like focus on this now. We are gonna talk about why we reduce the stiffnesses for cross sections later. But if you want to reduce the stiffness, you go to set modifiers here or modify modifiers. And then I have my beam here. If you want to add a copy of this beam or you want to add a new property, you come here again and then add the new property. Let's make a column C1 50 by 50 centimeter, and I'm gonna change this to 0.5 by 0.5. And if you want to add another column, you can add a copy of the property. And let's name it C2, for example, 0.25 by 80 centimeter. So if you want to change this, let's make the depth 0.8 and the width 0.25. And I'm gonna say, okay, this is an example of how to do the cross section. Your cross sections are gonna be with a bunch of mini cross sections. Some of them are steel, some of them are concrete. So basically, ETABS is helping you and giving you one of the most popular cross sections out there. So if you want to pick from them, you can pick from them.
Is there any way to tell if we're going to be using a normal weight concrete or a lightweight? Or
this you have to define a material. If you have a lightweight concrete, you have to define a material. It's called lightweight, and then the weight per unit volume is going to be changing. The regular one is 2.4 ton per meter cube. The lightweight, you can go down up to 1.5 ton per meter cube. So you have to define a new material for that.
all right.
And in tall buildings, maybe we will do that. Like maybe your structure is heavy and you want to decrease the weight. We usually use lightweight concrete in the slab, and we use ultra high strength concrete in the columns.
Another question, but if we use like a lighter concrete, wouldn't the drift of the higher stories, wouldn't they be like shifting more?
Why? The thing is, you are decreasing the masses that makes the building make this. So decreasing the mass is gonna decrease the deformation.
Oh, okay.
Right? We are gonna talk about this later when we study the dynamics of structure. All right, I'm done with the materials, so I'm gonna hit OK. I defined materials and sections. I defined the frame section, so I have to go and define slab section. By the way, here it divides the slab from the walls. Like back in SAP 2000, we defined all of them as shell, but here he's specific. You want to define a slab section or wall section. So I'm gonna define slab section, and I'm gonna add a new property. Let's call it, it's a slab 30 centimeter. And same concrete material, and I'm gonna name it here. They name them, like you will not find shell. Actually, here is the shell. Usually our slab is shell thin. not thick and not membrane and not layered, because we don't have a steel layer or something. It's one homogeneous material. So I'm gonna say shelf thin, and it's a slab section. And by the way, if you have a drop panel on your slab, we talked about flat slab was a drop, you can define the drop alone. All right, so I'm gonna change the thickness to 0.3 meter, and I'm gonna hit OK. And if you wanna actually add a new property, I'm not sure if we can find a wall here. We can find no walls. All right. So I define the slab, and then I'm gonna say OK, and I'm gonna define a wall section. I'm gonna add a new property, and let's say we are gonna make it walls 30 centimeter, and same material, and the wall is gonna be 0.3, and it's shelf thin, and that's only one section. We don't have to do anything else. I define the walls. Okay, do I miss something in the definition? Beams? Showing animation, please stop it. All right. So we have columns, walls, slabs, beams. We define everything. Okay, we're done defining sections. What is next? Load patterns, right? Do you guys remember the load, live load? So here it defines two load patterns for you, not one, like ETABS. It defines dead and live. And you will find out that he has already the self-weight multiplier 1. That means already it's going to calculate the dead load for you and put them in the dead load factor. And by the way, this is only the own weight. We have flooring loads on top of the dead load, so we usually need to go to the code according to our building occupancy. We need to find out, depends on the type of floor that we're going to have, how much flooring load we should put. Okay?
If we have brick veneer on the structure, like let's say a 4-story building, is there like an option to put it, or?
You can make, you mean like walls, interior walls? Brick walls?
No, brick veneers, like so you have like the facade of the structure, which have like the,
Well, if you have a facade that is really heavy, like glass or something, you have to find the load of this glass and what is the supporting system. Is it resting on the slab, on the tip of the slab? So you have to put it as a line load on the slab, like on the whole structure. So the facade, for example. So you have to account for every load of the structure. Like if your structure is like this, and there is a facade on this structure outside, and this facade is resting, for example, on a column or on a slab or a beam here. So this slab is going to take the facade load from here, and this load we're going to put it as a line load on the tip of the slab.
Okay.
And usually when we have structures big like this, assume that this is the floor system. Usually the live load is not uniform on the floor system. Like if you look at the ESC 716 for live load, they would tell you, okay, if you have a room that is a storage, it's going to have different live load. If you have a corridor, the corridor is much bigger live load. So we have to divide the slab into pieces, and every piece is going to take its own live load. So if you look at one of the big projects that is really being built, it's not, the slab is not one piece, or it's not, the load is not uniform. Every part of the slab is taking different load. But we simplify things here. So I just want you to understand the concept, how to use the software. If we keep doing everything that is done, we are not gonna finish. So yeah, but any loads you have to account for. All right, so I have did a live, and that's enough to practice in this class, so I'm gonna say okay. All right, so I have the loads are defined. So you guys tell me what is next. I define material, sections, loads. So I'm ready to draw the system, right? Okay, so what do you guys want to start with? Do you want to start drawing the columns?
The slab.
Slab? I'm gonna start with the columns. I'll tell you why. Because the thing is, I want to see, because I know, I'm not sure if you guys see the grids here. I can't see it on my computer, like I can see they are intersecting with each other. If I put the slab, I'm not going to be able to see the intersection of each grid, so I can't draw the columns. Drawing the columns here is really like, if you guys remember last time, we have points, and these points has hinges, and we extruded hinges to be columns, right? Here is much easier. I'm gonna close this 3D view so that you guys can see the grids. Let me zoom in. Can you guys see the grids now?
But it's no, we can imagine.
Okay, how about we display options, and I'm gonna see background or graphics and colors display, and let's make the background black background. How about that?
A little bit, yeah.
It's all black.
We can see them.
All right. Okay. So for the columns, I'm gonna draw like look here. This is the drawing. You can draw frames using these, and you can draw slab using these, and you can draw walls using these. Columns is this one. So columns, like if I click on this, so once I click, if you guys remember in SAP 2000, there is a box gonna open here, and it's gonna ask you what is the section of the column. This box is here. So basically it's gonna ask you what columns that you wanna pick. I'm gonna pick the column, the 50-50 centimeter column that I did from before. So I'm gonna click on this, and I'm gonna go all the way down to the C50-50. All right, right now this column is activated. So I know that I have this column here. Look what happened here. It catched the grid. Once I click here, it put a column. It catched the grid here, and I put another column here, and I believe there was a one here. Oh, this one was shifted a little bit. And there's one here. See what I did wrong. All these are not right, so I'm gonna delete them. And I have this one not in the right position, so I'm gonna get back here. This is called quick draw column. So I'm gonna draw the one that I messed up here, and I believe these all the columns that were 50-50. So if you wanna draw the corner ones, I'm gonna make them different. 25 by 80 centimeter. So I'm gonna put this one here, and this one here, and the thing is, right now it doesn't show the column as a point; it shows the column as a cross section. So let's actually see how this looks like in the 3D. You see? It's not only draw a point, it drew a column from this one and extruded to the next floor, and also put a boundary condition. So it did everything to you. So you don't have to select, assign, join, restrain, add hinge. It did everything for you here. And if you want to see this as 3D, there is something here it's called extruded view. So once you click on the extruded view, it's going to show you how the cross sections look like. All right. Okay, so this is the columns. Let's get back to the 2D view. So if you want to switch between 3D and 2D, that's 3D and that's a plan. And when you click on plan, it's going to ask you which one that you want to see. I want to see story number 1. This is the only thing that I have for now. Okay, I'm done with the columns. If you want to draw walls, so there's multiple ways. I would pick this one because I want to draw a column from a start point to an end point. So I'm gonna click on this, and when I click on this, a property object screen is gonna open here. I'm gonna say I want a wall 30 centimeter, and then I'm gonna draw the wall from here to here. So it's gonna draw the wall. If you wanna skip while being in the same drawing command, do right click if you click escape, it's gonna escape the whole order. So you have to do it again. So I did a right command, and then I'm gonna draw another one here, and another one here.
How do you change the from green to fixed?
From what?
From green to fixed, if you want to have a fixed color.
I'm gonna show you. The thing is, I forgot a grid here. So let me add a modified grid, modify, and I forgot one in the y direction at 2.75. So I'm gonna add 2.75 here, and hopefully it's gonna be one of them. And I'm gonna say okay, okay. All right, so here's the grid, and I'm gonna get back to wall drawings. And by the way, there's something that I forgot to tell you. When we draw a wall, there's two options that you can draw a wall with. There's something called beer and something called spandrel. And if you guys remember, yeah, can you turn on the light? Just 2 minutes. So do you guys remember when I talked about coupling beams? When you have two walls like this, and sometimes we connect the walls with something called the spandrel or coupling beam. The coupling beam, I told you it has a special reinforcement, and the thing is, if you model this beam as a frame, the walls are not gonna feel that they are connected. But here, if you connect them with a shell, it's gonna be connected on this whole area. So the thing is, if you have a coupling beam that is really, really stiff and is connecting shear walls, we usually draw it with a command that's called spandrel. It's a wall, it's the same section of the wall, but the wall is gonna consider it as having a wall section but acting as a beam. So it's kind of like you are drawing one wall that has openings, something like this. So it's kind of like a one wall that has opening. So we do this. You draw the wall with the option it's called beer, and you draw the beam with an option called spandrel. So if you come here, you're gonna find out that there's two options, beer and spandrel. Since this is a wall, I'm gonna keep it as a wall 30 centimeters. Okay, and I'm gonna draw the spandrel for you now, but let's actually finish the walls first. So I'm gonna draw one from here to here. And if you guys remember, I have a chord here. So I have chord like this, and I have another wall in the middle since we have two elevators for this building. All right, so this is the walls. If you want to shift and draw the coupling beam for this core, and also I want you to look at the 3D now. So this is how it's look like, and if you want to shift to the plan of story one, I can come back here. And let's see how the spandrel is gonna look like. Spandrel, and I'm gonna use the same section of the wall. Once I hit spandrel, it's gonna ask me, what is the depth of this spandrel? Okay, it asks you, is this depth above or below? Like, do you want this beam to be above the story or below the story? It's usually below the story. Because if you have the spandrel like this, nobody's gonna get in the elevator, so it needs to be like that. So I'm gonna put the spandrel depth, let's say, for example, 0.7. So I'm gonna say it's depth blue 0.7, and let's just start drawing this spandrel. So I'm gonna come here and draw this spandrel all the way here. So let's look how this is looking this 3D. Can you see how's the beam look like? It is the same section of the wall, but it is a shell element. This is provide more stiffness to the building. All right, so right now I draw columns, I draw walls. If you want to draw the beam, it's very easy now. Like I can come back to the plan, and I can big frame, and when I big frame, I can big the beam that I defined earlier, which is beam 25. So I can start by this point here. And then the thing is, alright, let's go to the slab. So right now I can draw the slab. So I'm gonna pick here slab 30 centimeter, and I'm gonna start with this point until I come to this point. So this made a slab in the whole plan. I want to void these two areas. You can actually switch it from a slab to something called opening. So you can come here and pick the area that has opening, and you will act like you are gonna draw a slab. And then it's gonna open the slab. Up. See? You have to keep dragging down.
Does it open the wall as well? In this case, or just the slab?
I think you can open the walls, but I'm not sure. Like draw wall if there's an opening in the wall, but we need to double check. All right. So here I have the system. You asked me if I want to change to fixed, so I can go to plan and I can go to the base, and you are gonna find your hinges here. You can select all your hinges the same way that we used to do in SAP 2000. Assign, joint, restraint, and do fixation, and your building is now all fixed. You go to this 3D, and you will find that this is the fixation. All right, so I have my geometry is done. So now I can actually pick all the structure and assign shell load, but I'm afraid that it's gonna put the load on the wall. So what I'm gonna do, I'm gonna go to the plan, because wall is shell too. So I'm gonna select this slab, assign shell load, and I'm gonna say uniform load, and I'm gonna assign, for example, I'm gonna put flooring load of 0.15 ton, and it's in the gravity direction. If you wanna change the direction, you can change it, and I'm gonna hit apply. And I'm gonna click on live load. I'm gonna put live load of 0.2, and I'm gonna hit apply, and then okay. If you wanna make sure, it says no selected options. Okay, I'm gonna select the object here, and then I'm gonna hit apply. So if you wanna make sure that the loads that you put are already there, you can right click on the slab, and then you are gonna find something called load assignments. You are gonna find that this slab has 0.15 depth and 0.2, and this is on top of the self weight. So also you are gonna find assignment of the sections. This slab has 30 centimeter section. So right now, this slab is ready for analysis, but we only missed one thing. What is it? Can I hit run now?
No.
The mesh.
The mesh, right? Let's say I'm not gonna do a mesh here. We will see what is this software is gonna do. This software has a self-meshing. And actually SAP 2002 has a self-meshing too, but the thing is this is much more powerful. So we usually use the self-meshing option, the automatic self-meshing. And the thing is this software, it asks you what is the mesh size that you want to run your analysis with. If you go to analysis, you check automatic mesh settings, and basically this software has an automatic mesh size of 1.25. If you want to decrease it to 0.5 meter, you can decrease it like this, and then you're gonna hit run the analysis. Let's save this.
Honestly, I did the homework and I just like did the copy paste of like while you were teaching us, but like, what's the purpose of the mesh? Like, why do we use it?
We talked about it. Actually, it's running now. Okay, can you turn on the light? Okay. So, we talked about it that all softwares are using finite element. Any software finite element, and then ANSYS, if you heard about ANSYS, it's used for research. We have to divide this into small elements so that we can increase the accuracy. Because finite elements only do the analysis of the joints. If you don't your accuracy is almost garbage.
Right.
But if you, the more mesh that you divide, the more the accuracy, because the thing is, it's gonna calculate here and here, and it's gonna average in between. Here and here is gonna average in between. If your mesh is big and you have this, so it's gonna base on the average between these 2 points. So try actually to run your analysis with a mesh 2 meter and a mesh 0.5 meter and a mesh 0.1 meter and see the difference. At some point, you will not find that there's a big difference after 0.5. However, if you make it very, very small, it might accuracy get really high, but the computational cost is gonna be more. But like, this is where you're gonna balance. Is that really worth it? Like, is that like, I have to wait 3 or 5 days to get results rather than getting a result in 1 hour or 30 minutes? And to getting like, rather than getting a bending moment of, for example, 2.56, I would get a bending moment that is the accuracy at the, after 6 and upwards. So it doesn't matter that much. Okay, so let's see how the analysis results look like. So, okay, the thing is, I didn't like what happened in the mesh here, but to be honest, it's valid, like it can work. But if you want your mesh to be uniform, before running the analysis, I believe in the automatic mesh option. Let's unlock the model. And let's analyze.
What's the one above this? This is for walls.
Oh, okay. Let's actually, we have to do for both. Okay, we forgot. Automatic settings for floors. It's 0.5. Oh yeah, I said I want a general mesh. I have to say I want a rectangular mesh. General mesh is fine and everything, but rectangular mesh is one of the most accurate ones. So I'm gonna say, okay, this is 0.5, and the same thing in the walls. I'm also gonna want to make them 0.5. I'm gonna hit OK. Run the analysis.
Does it tell you if it's failing as well?
If it's what?
If the slab fails,
What do you mean by fails?
maybe
The fail
the
is-
load is way too high in the span of
The only way to know it's failing or not, you have to do design. And once, the thing is, this is a structure analysis. So for example, it's gonna give you the deflection, for example, in the Z is 0.001. Is 0.001 is gonna make this a slab failing or not? That's, you have to check the code. So you have by, either by yourself or either by the app. If you try to design by ETABS 2000 and you hit the design button, it's gonna tell you if this is not failing. It's gonna tell you, is it like satisfying the design standards or not? So that doesn't mean if it's not satisfying, it's gonna fail. It just doesn't meet the standards. Same thing with reinforcement. You're gonna assume a specific amount of reinforcement and it's gonna tell you, oh, you need more reinforcement. All right, so so this is how it is. Like, it's the mesh actually looks great. If you wanna show deformant shape, so you can come here and show deformant shape due to dead load or live load, and actually you can do contour lines. And if I want to show the contour lines in the Z direction, I'm gonna hit apply, okay? So this is how the deflection look like. If you want to define load combination, you can define load combinations here. Add combination, maybe I'm gonna add 1.4 this. I'm gonna add 1.6 live load, and I'm gonna hit OK. Okay, if you want to change the deformant shape from load case to load combination, so you come to combination and then pick the combination that you want. And here you can find the new deformation. Alright, so that's for the deformation. If you want to show reactions, you come here, display support reactions, and you pick either load case or load combination reactions. We want to see FC. If you want to FY and FX, you can show them as well. And since we have fixation, so definitely we have moments. So here is going to show you everything. The moments and everything. If you want to show them one by one, which I think it's better in this case, so maybe I will only reactions here. If you want to increase the font size, you can come to options, graphic colors, or graphic preferences. I'm gonna increase the font size to 14 and make this to 5, the minimum, so that the numbers can increase a little bit. Yeah, so this is the reactions. If you want to show bending moment on the frame sections, so I'm gonna show the YouTube load combination. I want to show M33 here. Here it has really good advantage. You can see in the 3D how's the bending moment look like, and also if you are in the plan, you can see the bending moment. That wasn't in SAP 2000. Like in the plan, you cannot see the bending moment. Here you can see the bending moment. And at any point, you can visualize the bending moment. It doesn't show good in the black background, but if we change it to white background, numbers?
Yeah, 4
Yeah. So here's the bending moment. If you want to see the bending moment on the slab, so you can find M11 and I can hit apply. Okay, you can find the bending moment in M11. You can actually try this and try SAP 2000 and see what is the difference between the results. Okay, so this is for one story. If you want to make this a story, this one-story building to 10-story, I will have to unlock the model. That's number one. And I have to prepare grids for the 10-story. So I have to right-click, add and modify grid. I only have one story. There's something here that says quick add a story. So I can add 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can go to modify. And this is actually one of the most powerful things about the stories in ETABS. And this makes it really powerful tool for tall buildings. Why? Here you can define everything about the stories. Like you can make the story heights different. Like you can make one story 4, another story is 5. Let's say that, oh my God, I made the versus story 3 meter and it's supposed to be 6 meter. If you change the story 1 to 6, it's gonna extend everything to 6. Extend the column, extend the slab, extend everything. And also, one of the most powerful thing about this that you can make master stories. Let's say that we have a 100-story building, and you have one story and another 5 stories similar to this story. But after that, there is different one, and there's 10 stories similar to this one, and there's another 6 stories similar to the other one. So you can define which one of these are a master story and which one of these are similar to each master story. For example, you can come here and say, okay, this story is a master story, but this one is not a master story. Once you say it's not master story, this tab is gonna open, it's gonna ask you, this story is similar to which story? I'm gonna say it's similar to story 1. And you can say this is no, 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 and I'm gonna say here that all these are similar to story 1. And I'm gonna say this is a master story, but these ones are not a master story. And I'm gonna hit that all these stories are similar to story number 6. Alright, so I had this, and I have...
You're missing one of them.
Okay, yeah, let's make this one similar to story number 6. So the master stories, it cannot be similar to anyone. But the other non-master stories can be similar to the master stories. Alright, let's say okay and okay. How this is helping us, let's say for example, you forgot to put a load on one of the stories. Like let's say story 1, that is master story, you forgot to put live load. In this case, when you assign load, you can say ETABS to ETABS. Put a load on story 1 and all the stories similar to story 1. So basically it's gonna change everything in the master stories. And this is very helpful, sometimes you forget a beat. or you want to add beam to a master story, or you design something and you find it's failing, so you have to change something in a story. So you want this to happen to all similar stories. This is really big issues when you have a huge number of stories, which makes ETABS 2000 a really powerful tool. How this is going to happen? Look here. There's an option here. It's called one story, and if you click on it, it's going to have multiple options. It's called all stories, similar stories. What does that mean? If you are on the option of one story, so anything that is going to change to this story is not going to change to other stories, even if it's a similar. If you want the changes that is going to make to this story to be changed to the similar stories, you have to check similar stories. If you want to do something that is already in all the stories, similar and not similar, you hit all stories. Like let's say you forgot to draw a column. And this column is coming from story number 1 to story number 60. It doesn't matter if it's similar or not similar. So once you draw this column in story number 1 and you set all the stories, it's gonna draw the column for all the stories. If you have a similar stories, let's say you draw a beam in a story and you want to change this in all similar stories, you hit similar stories. So this is really, really powerful. I never felt how powerful it is until you deal with really, really big building. Do you guys remember when I said there's multiple loads and multiple pieces? This rule is really powerful when you want to add more loads or change pieces of loads and all these things. Okay. That's for the stories. Let's go to the 3D. So right now I have all the grids ready. So all what I have to do, I have to select this story and replicate it in the 10 grids. So select, to do this, I have to adjust the view a little bit so I can help me with the selection. I'm gonna say set 3D view. I'm gonna say XV. I'm gonna make the aperture angle 0.
Because you don't want to select the...
Yeah, I don't want to select the
supports.
edges. Yeah. So here I selected everything. And right now I can edit and I can go to replicate. And in replicate, there's multiple options. There is something called linear, radial, mirror. I want to do a story replication. In a story replication, you are going to tell ETABS, where do you want this story to be replicated? I want to replicate this story from story 1 to story 10. So basically I choose 1 and shift and choose all of them. So basically it's going to replicate this whole story in all 10 stories. But I don't want to delete the original because the original is still in the page. I want to keep it. Okay, so let's say okay, and then our 10-story building is here. So, and if you want to see extruded view, you click on this button, and then you are gonna find the 10-story building. This building is ready for 3D lateral load analysis, and this is the only need for 3D model is to do lateral load analysis. Yes.
How do you do that command with when it's in 3D that you don't have to click the rotation? Like how do you make
How do I do the rotation?
Yeah.
Rotation, basically, with the scroll here, if you click on the scroll and you keep moving, it's gonna make it like this.
Right.
But if you have shift while scrolling, it's gonna do rotation.
Didn't the replication duplicate the first story? I think the story was already there.
In the replication, I replicated only in story 1, 2. Oh, you are thinking that I have 2 stories in the same. Okay, let's see.
Maybe it knows, but it doesn't.
Okay, let's get. All right, if I deleted this and oh, it's only 1, so it's not duplicate. So if I click on this. Okay, if you want to make sure that there's no 2 elements, you choose this. If it's see 2 shells, that means it's duplicate. All right. Okay. So I have this building. All right, and we have 10 minutes. I'm gonna show you how to do this building in 10 minutes. Again, we spent over an hour doing this building. Let's see how we can use AutoCAD import and import this building into ETABS in 10 minutes. Hopefully it will take 2 minutes. So I have here AutoCAD. So the thing is, if I imported this AutoCAD to ETABS right away without any modification, it's not gonna work. The only way that AutoCAD can see structural components, you have to prepare the AutoCAD file for structural components. So ETABS can see columns from AutoCAD file if you have a closed line around the column. Maybe it's gonna take more than 2 minutes because I explain a lot. So look at this. This column, ETABS can see it as a column if there's a lines that are connected. Like let's say if you draw a broken lines, like let's say you have your column is like this. And you click, it's not connected, it's just the broken lines. ETABS cannot see it. So how you can do it? You either join them, or when you draw the column, you make a pulley line. Pulley line, the pulley line is like a connected line. Like, okay, let me connect this here. So if you click on all this and make join on AutoCAD, so basically once you click on this, it's gonna be one piece. Alright, that's a pulley line or a connected line. So this is how ETABS is gonna see a column. So you have to have your columns not in a group, not in a block. It needs to be separately. Like sometimes we group the columns with the hash. So it needs to be separately from the hash. Okay? So this is how ETABS is gonna see columns. ETABS is gonna see walls, same thing like columns. You have to have a pulley line around the columns like this so it can't see it. Like if in the core, it needs to be the same thing. Like if I click on this, it's only one piece.
Why does the hash has to be separated from the polygon?
Because the thing is, if you brought that, the thing is, if they are both in a block, if you import it to ETABS, ETABS doesn't see blocks, only see separate layers.
Okay.
And actually, hash is a block by itself because it's multiple lines. So actually, once we import this map, we're not gonna see the hash on ETABS because it's a block. Beams, it's shown as lines. So draw a line in the center of the beam or in the edge of the beam so ETABS can see it. So here, you'll find that I draw a blue line here. The blue line is for the slab actually. The beam, okay, let's see, I have made a layer, and this layer is called slab ETABS. So I made 4 layers. These 4 layers here, one of them is called beam ETABS, columns, and slab ETABS, and I believe I have one, it's called wall ETABS. Yeah, here. So, and I have them in a group, and not in a group, I mean like here in the map. This is the only 4 layers that I care about because I'm gonna convert the wall into structural wall and the beam in a structural beam. So every layer is gonna be converted into a structural component. So once you have all this done, you go to save as, and you save it as a DXF, not DWG. So you go here and it changed the savings here to DXF, and I'm gonna save this as building 10-story version 2. And I'm gonna say okay, and I have to close this. Like I have to close this file. All right. So and then let me start. Actually, let me save as this. Save as. And I'm gonna call it version 2. And let's delete this whole structure. Okay? Why I did this? Because I don't want to define the material, define the sections, define everything. Okay? Alright. So what are you gonna do? You are gonna go to file, and then you will, in file, you are gonna have import, and import, you're gonna find something called import DXF or DWG file of architecture plan. So when you click on this, it's gonna ask you, where is this architecture plan? I'm gonna say, this is my architecture plan version 2, the one I just named. And it's gonna ask you the units of this drawing. I'm gonna tell him that the units are meter, and put this plan in a story number 1, and the scale factor, don't scale it, and okay. All right, let's go to story number 1. This is the story number 10. I'm gonna go to plan, story 1, apply, okay. Here is the architecture plan of the drawing. By the way, this is not a structural system. This is just a drawing gonna help me to generate the geometry. Yes?
Does it import the grid lines as well, or no?
No, it doesn't import the grid lines. Okay, but I believe if you wanna have a grid lines, I'm not sure if it adds a grid lines, but I don't need the grid lines for now.
Yeah,
because
that's exactly
I'm gonna
right.
draw them.
Yeah.
Alright, so let's actually convert this drawing into structural system. Can you see here the model Explorer? You click in this plus and you click on plan view and you click on architectural layers, all the AutoCAD layers are gonna show up. Okay, so let's see how we can draw all the columns in the structure in one click. I know that the columns are in this red layer, columns. By the way, the hash is not there. So all what you are gonna do, you are gonna right click on columns, and then you are gonna say add column object. So in one click, you draw all the columns in your structure. And by the way, since you already defined C5050 before, it's gonna assign the section C15050. If we didn't, if we start by new file, it's gonna develop its own section. It's gonna make a 50-50 section, but it's gonna pick the default material and the default everything, which is actually what we did exactly. We picked the default material, but it's gonna name it F section 1, not C15050. But because he already found this section already defined, so he picked it right away. All right, we are done with the columns. Let's do the walls. So I'm gonna come here and I'm gonna go to wall ETABS. And I'm gonna right click and I'm gonna say add wall object. So it draw wall object for all the location of the walls. Except I don't know why it didn't draw the wall here. I tried to figure it out, I don't know. Maybe try to do it at home, make the polyline right, and see if this is gonna be, because it's usually okay with me, like I never had this issue, but actually it's very easy for me. I can go to plan 1, story 1, and I can draw the missing one here. And I can make sure that this wall is here, and it's not opening. Actually the wall has openings, and I'm gonna draw wall centimeter, and I'm gonna draw one from here to here. And I'm gonna go to 3D, and I have all the walls. If you wanna draw the beams only have one issue. I'm gonna go to beam ETABS. I'm gonna add beam object. So the beam object is already added, and actually it picked the beam that we already defined. If you didn't have a beam already defined, SAP 2000 make a beam section is called none, which is a dummy beam that doesn't have any stiffness. So you have to select all the none that the SAP 2000 defined and assign the new section. But we are fortunate here that we already have a beam already defined to pick from. So we assign this beam right away. Last one is the slab. So I'm gonna go to the slab ETABS, the layer. By the way, slab you only make, this one. For the slab, you only make a rectangular area. Like, can you see here? I draw one big rectangle. That's actually all what in the slab ETABS. So coming to ETABS, I'm gonna assign add area object. Alright, let's click on this and see what sections we have here. This slab is assigned a section wall 30 centimeter. If you want to change it, you go here to slab 30 centimeter and say okay. Now it's a slab. Right click, it's a slab section. For the walls, I'm gonna go, for the openings, I'm gonna go to the plan.
So define the spandrel as a beam.
Oh, it makes the span because I draw a beam line in this area. I made it as a beam. If I want to change it, I can change it to redraw the beam. Okay, I can draw an opening now. So I can come to opening, and then I can make this, and another one here. So if you want to redraw this, I can delete this beam, and I can come to walls, and I can say it's spandrel, and the cross section is not opening its wall, and then it's 0.7, and then I will come here and draw it like this, and then I will come to And then if you want to replicate it, actually let's select all this and see if it's going to replicate the hinges. Edit, replicate, stories, and then I want to replicate this. I don't want to do the base. The base I already have it. Story 1. And I'm going to hit apply. Alright, let's. Yeah, we shouldn't pick story 1. But it didn't show that there's replication in the last one. Okay, I'm going to hit replicate. And let me zoom in. There's no hinges in the stories. Oh, actually there is. Can you guys see it?
Yeah.
I can see it. So let's do Control Z.
Maybe just in the top.
No, I believe it's everywhere. I just looked at the top. So I'm gonna make this 0. Okay. Sorry. View. Set 3D view. XZ. And then I'm gonna select this without the hinges. Edit. Replicate. Story 2, and right now we have S3D. All right, so this is how to do the whole thing on ETABS. I'm gonna send you the project today because it's gonna be a tube system and it's gonna be on ETABS, and I'm gonna show you a tube system, the structural system. I'm gonna explain what is the tube system is. But the thing is, I'm gonna give it to you so that you can know how does the plan look like, how many columns, how does the structure look like, and then next time we're gonna start, what is the lateral load resistance system? There's something called a frame the tube, outrigger system, shear wall system, bundle the tube system. So we are gonna see what is the different systems is and what is our project is gonna be. All right. So is it difficult? Easy, similar like SAP 2000. I don't see it's that big difference, right?
Seems easier than
Okay, sounds great. So see you guys next time.
One question.
All right.
Daniel.
Ustedes lo piden su examen que él no lo ve.